So yesterday we were talking about getting radicals out of the denominator of a fraction, and the first page was all about square roots, and then we started looking at bigger roots. And yesterday we looked at the third root, and here's a problem where we have a fifth root of something in the denominator. And so remember, when we want to get the radical out of the denominator, if you can't simplify it, and here, what powers do we need things to be raised to in order to simplify? 5, right? If it's the fifth root, we need the fifth power. So there's only a to the first and b to the third. So there's no way we can simplify it the way it is. So we're going to have to multiply top and bottom of that fraction by a radical. And if it's the fifth root here, it's going to have to be the fifth root in what we multiply by. And so remember, we want to totally get rid of the radical on the bottom, which means we need things to the fifth power. So for the a part, what will I need to multiply by? Yeah, a to the fourth. And for the b part, what do we have to multiply by? B squared, right? Then if we just multiply straight across, in the top we have -3 times the fifth root of a to the fourth b squared. And in the bottom, we'd have the fifth root of a to the fifth, b to the fifth, but then each of those simplifies. Since the power matches the root, we just get ab in the denominator. Let me just make up one more so we can practice. I'll do a fourth root this time. Let's do the fourth root of, let's do 24 over, let's do x squared y cubed over x, let's do 25 x to the 7th y. Now, if you wanted, you could right away split it up as the fourth root of the numerator over the fourth root of the denominator, or you can ask yourself, can I do things to simplify under the radical first? And, well, the 24 and 25, you can't do anything with that. What about with the x's? Where are they going to be left in the denominator, and how many? 5, right? So I'll still have a 24 over 25, and I'll have x to the fifth left in the denominator. And what about the y's? Where will they be left in the top, in the numerator? And how many? 2. Right, so we'll have y squared. Now I would split it up as the fourth root of the numerator over the fourth root of the denominator. And then see if we can simplify anything. So let's look at some fourth powers. 1 to the fourth is just 1. 2 to the fourth is 16. 3 to the fourth is 81. So already we're too big. None of those can you factor something out that's to the fourth power. 4 to the fourth is 256, and 5 to the fourth is 625. Okay, so as far as the numbers go, we can't simplify the fourth root. But with the variable in the bottom, what powers do we need things to be raised to? The fourth. So with this x to the fifth, I can think of that as x to the fourth times x, right? And then this power matches the root. So what's going to come out in front of the radical? An x, right? So we'll have the fourth root. I can't do that with the y squared. I don't have enough of the y's. So 24y squared over this x to the fourth is what comes out in front of the radical. We're still left with 25x underneath the radical. And that won't simplify, so we're going to need to multiply numerator and denominator by a radical. Need a new lead. And, yep, so, and it's going to have to be the fourth root, and we want things to be to the fourth power. Okay, so 25, you think of what's the smallest number you can multiply it by to get something that is a fourth power. Well, if it's 25 and you're going to multiply it by something, it's going to have to end in 0 or 5. So you can't get any of these first four, but if you do 625 divided by 25, oops, that is 25. So you would want to multiply top and bottom by 25. And how many x's? 3. So x cubed. So in the bottom, we still have that one x out in front, times the fourth root of 625 x to the fourth. And then in the top, we're going to have the fourth root of 24 times 25. Is that 600? And it doesn't matter what order you put the variables in. You could put it y squared x cubed, or you could put it x cubed y squared. I usually do it in alphabetical order, but it doesn't matter if you put the y's first. I'm kind of running out of room since I didn't initially plan to do this problem here. The fourth root of 625 is 5. And the fourth root of x to the fourth is x. So simplifying in the denominator, we get the numerator stays the same. 600 x cubed y squared over, so we have x times 5 times x, so that's 5x squared. And, I mean, you could see if you could simplify 600, but obviously, well, 256 is not going to go into 600, neither is 81. You could try 16, but you're not going to be able to factor out, see, it doesn't go in evenly, so you're not going to be able to factor out any fourth powers from that. Because there was an x out in front of the radical from that x to the fourth at the very beginning. Okay, so all of these denominators just had one term, the ab cubed, 36z squared. So now we're going to look at rationalizing denominators that contain two terms. So it says, first, if we have a term that looks like a root b plus c root d, its conjugate is a root b minus c root d. So you keep all of the same numbers there. If it was a plus at the beginning, you change it to a minus. So if it was a minus at the beginning, then you'd have to change it to a plus. So it's just, you keep everything the same except for the sign between the two terms. So it says to rationalize a denominator that contains two terms, we use the conjugate. So that's why we talked about it. We're going to have to use the conjugate. And the fact that if we have a plus b times a minus b, so remember, we're going to have the same thing as the first term, the same thing as the second term, but one's going to have a plus and one's going to have a minus. And this is the formula for factoring what? Difference of squares, right? So that would give us a squared minus b squared. You can also check with FOIL. The first terms would give you a squared, the outsides would give you minus ab, the insides would give you plus ab. So they would cancel, and the last terms are minus. Positive times negative is negative b squared. So we're going to, once we FOIL out, everything's going to be squared, which will help us get rid of the square roots. Okay, so let's do some examples. So we want to rationalize the denominator, and this has two terms. So we're going to multiply both top and bottom by root 15 plus root 6. So we know we're going to get a squared minus b squared. So we're going to get root 15 squared minus root 6 squared. And if you don't remember that formula, you can always do FOIL. That's fine. But now in the numerator, we're going to distribute the root 3 to each term. So root 3 times root 15 is root 45 plus root 3 times root 6 is root 18. Okay, no, that's fine. So let's look at the denominator first. What's root 15 squared? Just 15, right? Squaring cancels the square root. Minus 6. Okay, well 45 and 18 are not perfect squares, but we should see if we can simplify them. Is there a square that goes into 45? 9, right? So we want to think of the 45 as 9 times 5. And then 9 will also go into 18. Okay, so in the denominator, 15 minus 6 is 9. And then what's going to come out in front of the radical here? 3, right? Because square root of 9 is 3. So we have 3 root 5 plus 3 root 2. Can we combine those two terms? No, they're not similar radicals. Okay. Can we do something to factor the numerator? Yeah, we can do what? Take out a 3. And so if we factor out that 3, we're left with root 5 plus root 2 all over 9. And then will that simplify? Yep, because the 3 goes into 9 3 times. So we end up with root 5 plus root 2 all over 3. Uh-huh.
Just curious, like, why can't you factor out square root of 3 on the denominator?
You can. You can, but if you factor out a root 3, you're still left with root 5 minus root 2. So you still have radicals in the denominator.
Oh, okay.
We're trying to get rid of all of the radicals in the denominator. You could have done that, and then you would have to multiply top and bottom by root 5 plus root 2 and still do like the FOIL in the bottom and stuff. Okay, so the next one, radicals in the bottom. We can't, nothing here will simplify. You can't simplify root 6 or root 7. They're not similar radicals, so we can't combine. Oops. So we're going to multiply top and bottom by the conjugate of the denominator. So keep your terms the same. 2 root 6, 3 root 7. If it's a minus here, its conjugate has a plus. So in the denominator, that's the formula for the difference of squares. So the first one squared minus the second one squared. And again, you can always do FOIL and you get the same answer. In the top, we have to do FOIL. Okay, so first times first. So 3 times 2 is 6. And then root 6 times root 6, root 36. Okay, so that's first outside. So they're both, everything's positive in the numerator. So plus 3 times 3 is 9. Root what? 42. And then the insides plus 5 times 2 is 10, and root 7 and 6 again, so root 42. And last terms. 5 times 3 is 15. Root what? 49. Okay. So in the denominator, I'm going to do that first just because it's a little bit easier. So when you square 2 root 6, you have to square both the 2 and the root 6. And when you square 2, you get 4. And when you square root 6, you get 6. Minus, so when you square the 3, you get 9. And when you square the root 7, you get 7. Okay, so now let's move to the numerator. So 6 times root 36, which is, right, 6 times 6, so at the end we'll get 36. And I'll combine these two before I think of simplifying, if we can. They're similar radicals. They both have a square root of 42. And so we're going to have a square root of 42 in the answer. And what goes in front? 19. And then the last term is plus 15 times what? 7. Okay, so now let's simplify even more. So that's 24 minus 63. 36 plus, well, 42 is 2 times 21, and 21 is 3 times 7. So there are no squares that go into 42, so we can't simplify that at all. So that's just going to stay 19 root 42. And 15 times 7 is 105. So let's see, 24 minus 63 is at negative 39. Yes. Can we simplify in the top? Yes. 36 plus 105 is 141. Plus 19 root 42. And then we want to see if we can simplify. Well, 19 is prime, so the only way I could factor is if 19 went into 141. And it doesn't. So there's nothing we can do to factor it out. If that was an 18, then they do have factors in common. 3 goes into 39 because 3 plus 9 is 12. 1 plus 4 plus 1 is 6. So make sure, especially the 3's, that's easy to check to see if 3 goes in. But since it was a 19, that didn't work. And this is our answer. You could also put the negative out in front of the fraction. That's usually what Math Excel will do. Okay, so the next one has radicals in it, and we can't do anything to simplify square root of x, so, but we want to get the radicals out of the denominator. So we're going to multiply numerator and denominator by the conjugate, so square root of x and 4, but this time here it was a plus, so now we want a minus. So multiply top and bottom by square root of x minus 4. And then in the bottom, doing FOIL gives the difference of squares, so we'd have the square root of x squared minus 4 squared. Ooh. And then in the numerator, we have to do FOIL. So square root of x times square root of x. Yeah, so that'd give the square root of x squared. The outsides, positive times negative, so minus 4 root x. And then insides, also minus 4 root x. And last, negative times negative is positive. 4 times 4 is 16. So on the bottom, square root of x squared is x. And, well, you could think of, I didn't say assume all variables represent positive numbers in this one, but here it wouldn't make sense for x to be negative. You can't have a negative number on the square root, so it's implied here that x is positive, so we don't really have to worry about absolute values for this problem. Minus 4 squared is 16. And then in the top, square root of x squared is x again. We can combine the two terms in the middle. They both have square root of x, and what's going to go in front of the square root of x? Negative 8, and then plus 16. And then that's all we can do. There's nothing we could factor out of the denominator or the numerator, so this is our answer. Mm-hmm. Mm-hmm. If this was a plus right here, then we would just change this to minus. The next part would still be minus because it's still difference of squares formula. If you have the same terms but one positive, one negative, regardless of whether the plus is first and minus is second or minus is first and plus is second, it's still the difference of squares. Like this one had the plus first, right, and the minus second. Mm-hmm.
Yeah, this is like a square root. It's not putting on a 4. What does that mean? Like,
So this, the 4 is totally separate. So this, like, it's totally different from the square root of x plus 4. Those two are completely different because here if you were to plug in x equals 4, that would be square root of 4 is 2. So you'd have 2 plus 4, which is 6. Here, if you plugged in x equals 4, you'd get the square root of 8. And you could think of 8 as 4 times 2, and you could bring a 2 out in front and get 2 root 2. So the answer here is 6. The answer here would be 2 root 2. So they're completely different. Mm-hmm. Mm-hmm.
on that answer, did you multiply by just x over x? Wouldn't that get rid of the square root of x?
If you multiply top and bottom by square root of x?
No, just x.
Just x? How can x get rid of a square root?
Well, if square root of x times x, wouldn't that be x square root of x?
Yeah.
I was thinking you put the x square under the square root.
Nope, you only, this x times square root of x, so just think of numbers, right? So if x was 4, that would be 4 times root 4, which would be 4 times 2 or 8. But the square root of x squared, if you plug in x equals 4 there, you'd have the square root of 16, which is 4. So totally different answers. Yep. If it's not under the square root to begin with, you can't put it under the square root.
So you would have to multiply by square root of x.
Well, yeah, to get rid of that, but then that would put a radical back in the denominator. Okay, that was it. I'm going to go ahead and do 7-6 right now. Oops, and then I'll have you do those two, the 7-6 group work and the